Thank you for the welcoming presentation. I'm from Montreal, as you all heard, so it's always a challenge to be in Boston. I'm a Habs fan, so always trying to watch my back a little bit here. But all that being said, I did a lot in the last 20 years, but I think my greatest accomplishment is to be a proud father of 3 kids that I cannot deny. I'm here today to talk to you about the Turcot project. Turcot project, when we were contacted by DRE KHL to present the work, we were first really honored, and then we asked ourselves, how can we present 2 years of works in 25 minutes? That's another challenge, and the way I'm going to present it to you is that we're just going to go quickly over the scope, and then after we try to highlight the main challenge that we have during the project. And instead of using video and many slides, we're just going to walk through all the pictures that we're taking in the last 2 years, so you can really relate on the site conditions and all the challenges that we have to live with within the project. So we say it's a success. Why it's a success? Because we reach all the milestones that we give ourselves early in the project, but there was a lot of challenge behind that success. Who is Delsan Aim? I won't spend any time on this. We only have 25 minutes. Everybody's hungry, so I'm going to go fast. As they said, we're in business for 25 years. I joined the team 5 years ago. We're owned by Aim, American Iron Metal, which is the main scrap recycling suppliers here in North America. And what led us to Turcot? It was a challenge for us to reach the level of expertise to be able to tackle that job. As was mentioned before, civil work was not something that Delsan was used to do in the past. And when I joined the team with my partner Lorenzo, which is here, that I thank very much, we started to work on different projects. And within 5 years, we were able to really put ourselves into the market, mainly in Quebec. We worked on 20 civil projects and demolition more than 35 structures, mainly bridge overpass and also highway interchange. Please click. That's a brief overview of all we have done in the 5 years on Google Earth. We've done a few projects in Ontario. There's a lot of work there. It's a tough ground. Priestley is really strong, which is here. I salute him. And then we worked a lot in Quebec, obviously. We went north, we went south, we went through. You can see Quebec City. Our head office is in Montreal. This is all the little project that we did that lead us to Turcot. We're going to see quickly one of the biggest and first biggest challenge that we tackled was the Bona Expressway, which is, as you can see, downtown. It was an elevated structure, really looking similar as Turcot. And then right after, we switched in 2015 on the new Champlain Bridge project. All this highway corridor was fully demolished by ourselves. There were 15 overpass, 500 meter long concrete bridge. And then you can see all this highway network linking all the way back to the heart of the Turcot interchange. So briefly, we're gonna oversee what was the scope of the project. The owner is the MTQ, Ministry of Transport of Quebec. The general contractor was led by Kiewit. It was a joint venture by Kiewit, Parson and Olsen. Kiewit is here, I salute them also. Project contract value is around $2 billion Canadian, scheduled from 2015 all the way to this year. I won't comment if they're going to be finishing or not. I don't have this information. Within that project, there were 15 kilometers of highway and structure to be demolished, and then that combined into more than 300,000 meter cube that was processed and also reused on site by the general contractor. Delsan's scope within that project started in 2017. We did some preliminary work 2015, 2016, but the main contract was from 2017 to 2019. Within our scope, we had 15 infrastructure to be demolished, mainly highway ramps, as you can see here in the picture. The height was from 10 to 33 meters up in the air. We had a railway tunnel that we're going to see later on, and we almost demolished half of the total quantity of the project. We had a lot of support from Kiewit as a collaboration effort. They provide all the traffic mobility, they develop all the phasing, they did all the embankment work, and also temporary false work that needs to be done for us to be able to perform, and they also participate in some of the engineering of the means and methods. We estimated that job almost in 2016. We're going to see the schedule later on. It was obvious that there was a lot of unknown conditions. The interchange was under construction when we were regarding the drawings. So when we get into an agreement with KPH, which is Kiewit, we agreed that we were working on a two-way contract, lump sum from any fixed element that can be done now, and also a target pricing system for any unknowns, and also mainly protection. There's some engineering, and also the pier stability that was a challenge in the job. Again, quickly, the working schedule, as I say, we started bidding the job in 2016. We were awarded the contract in early 17, and then we started the engineering and procurement process along with Kiewit. We did phase one, which is about 1/3 of the entire scope in 2017, 2018, and then in fall 2018, we had a huge push to produce and deliver the project all the way to last June. On the project, we mobilized a lot of resource, mainly excavator. Our main goal within that project was to do the maximum mechanical demolition as possible. We thought that it was the safest way to go with proper protection instead of going crazy with lifting device and on saw cutting. So we mobilized a total of 6 high reach on the job, but we never had more than 5 at the same time, averaging from 70 to 120 feet. 944, all levers high reach, 944, 950, 954, 960, and also 974 for the highest part of the project. We also had more than 20 standard excavator from 20 tons to 70 tons, 12 hydraulics hammer full-time, multiple shears and different attachment. We had a maximum workforce peak, 50 guy, almost all operators, plus the staff engineering, all that working 7 days a week, 24 hours a day. So we're getting into the heart of the presentation. So we're gonna look at all the challenges that we face and all the innovation or engineering solution that we use to tackle those challenges. As you see in the pictures, we're gonna see it also later on. It was really a dense urban environment. All around us there was something, either house, industries, roadways, local street, name it, everything was there. The traffic mobility was one of the biggest challenge. It has to be maintained at all time. We were not allowed to close any lane. We have to keep traffic mobility. The only closure that we were allowed was a standard weekend shutdown. So we had to deliver every weekend during almost 6 months. Dust, always, it's a challenge for everybody here. I think everybody's speaking about dust. We're going to see later on what kind of solution we have. Obviously, we're in Canada, so it's cold 6 months out of the year. And also the schedule was really, really tight, and the milestone needs to be reached to give Kiewit the opportunity to deliver the project on time. First challenge that we're going to look at quickly is the traffic mobility and the construction phasing. As I said, KPH or Kiewit needed to keep the mobility at all time. So it was a standard solution. Kiewit had to partially build new construction to be able to decommission the existing structure for us to demolish, and then after for them to finalize the construction. That's easier said than done. I put my hat up to Kiewit for developing that phasing. It was really, really a key challenge into the project. Here we're going to oversee, it's kind of the following of the last video. We're going to see the existing condition. South of the picture, you see that's a 6-lane highway, north and southbound, going from the Champlain Bridge project all the way up to the heart of the interchange. The white line that you're gonna see here is actually a new bridge in construction. That was a 3-lane to be able to decommissioning the bridge on top, at the shoulder, sorry. And then we're gonna move a little north to the heart of the interchange. The blue body that you see here is the channel. We're gonna see it later on. It was one of the challenge also. That's the east end of our scope. I have to mention that the project was going a little further east. It was performed by one of our competitors with Kiewit. At the bottom of the screen, that's the north end of the project. You see dead center, those 2 high ramps that are 110 feet up in the air, spanning over almost everything, and also 4 main railway lines that we were not able to shut down at all. No train could stop for us unless there was huge liability with that. And then you see the south section going up high in the air over the channel there. As you can see, this is a heavy, dense urban area. It's the heart of Montreal. Everybody's commuting by that interchange, and everybody was impacted by the work. This 3D model is just to highlight the kind of conflict we had to deal with. The existing is the dark gray, which is much higher than the new, which is gray, a lighter gray, if I may say. You can see everything is built underneath, lower. That was the purpose of the design. But you can see the kind of conflict that we're dealing with. So the solution was to stage the work to be able to partially close lane, switch traffic, and start demolishing. And also we had to work during lane closure at night and weekends. That was the heart of the production, was always at night and weekend. And also we had to design custom protection device so we could mechanically demolish the ramps and everything above the new structure without affecting the structural integrity. Quickly, that's a modeling done by Kiewit of the type of staging that we're talking about. At that point, traffic from the top is switched to the bottom. And then you can see how they construct all the structure around the piers, underneath the structure, the old ramp, and also build embankment around piers for them to be able to switch traffic and then for us to demolish it after. The structure, obviously, since this was to be demolished, was really old. Really, it was rusted. The drainage was bad, and also the type of structure that was, it was a 3-portal system sitting on concrete piers with pins at the bottom. So it was just wanted to collapse by himself. So we have to ensure that the new structure will not be affected by that, but also that our worker could safely demolish the ramp without any chance of collapse. And obviously everything has to be protected into the vicinity of the work, major time constraint. Please, can you start the photo album? So we're gonna walk through on those pictures quickly. That's in May 2017. This is when we started into the design. You can see the type of site condition that we were dealing with. You see a lot of new construction all underneath. You see the new railway being built. That's the east approach. You see the new bridge. That's, again, north-south. Everything underneath is under construction. That's the channel that I was talking about that needs to be protected. You see the bridge in construction. That's real-life picture of what it was looking like on site. Again, this is when we started in May 2017. Here, that's the new bridge. That's exactly what you saw into the model before. The bridge was built around the piers, the backfill, new construction. I'm gonna fast pace those pictures a bit. These are the type of prep work that were done by Kiewit. They were building embankment, shoring, for them to be able to finalize the construction. They also cut some columns. You can see how tight it is at some point. These are new tunnels to accept the new railway that was built. and then all around. This is like 60 feet up in the air. You see the conflict here again. A few that you see. So from that on, it was obvious that we need to develop something that was feasible, fast, safe, and also in line with the technical requirement of the project. This is May 2019. After phase one, you can see that most of the east-west interchange is already gone, all demolished mechanically. We're going to see a picture later on of what the work was looking like. But again, you can see that at that point, they were starting to build the new north-south alignment all underneath the new structure. I'm going to fast pace to this. I think it gives you a good sense of the proximity of the public also, the road, the new construction, and all the stuff that needs to be done for us to tackle this work. Can you switch back, please, to the presentation? Thank you. So again, the solution is always, in our mind, engineering, as to engineer a good sequence of work for the high reach to be able to work without any chance of collapse. And then after, we had custom-made protection. We had to stabilize almost all of the piers. As I was explaining, the footing and the column were not linked together. The joint was at the bottom, so as soon as you cut the continuity of the span, there was a chance for the piers to collapse. And it did happen at some point into the project for other contractors, so we intensely sit with Kiewit to develop something that worked, and I'm going to show you later on. So that's the sequence that we came with. You see the structure was built with concrete box cells, if I may say. So the idea was to start one cell at a time, and then when we started the last cell, we were cutting it with overhang to be able to isolate the last wall and then chew it slowly and keep all the rebars without cutting it. Because if we were cutting the rebar, this is where there was a chance of collapse. You'll see the picture after. That's what we developed to stabilize the piers. Basically, it's kind of a counterweight system. We use old sea containers, 20-foot sea containers that we stack together, that we put counterweight, ballast, whatever you want to name it, inside it. So, and then after we built a frame that was reusable, that we could clamp to the piers. So then when the piers starts moving, there was a big ballast or counterweight here that was keeping the piers from tipping down. And then after we can use mechanical hammers to hammer the piers top to the bottom. We designed two, let's say, special device or deflector that we use largely in the north-south demolition. These equipment main purpose was to deflect the concrete falling down, avoid any hit on the structure, and everything was on wheel. And also we had extension that we put crane mats and rubber mats on each side. So when there was a hit, there was no vibration transfer to the structure. And all the vibration was really monitored at every weekend, every move by Kiewit, sorry. Another device that we designed was for the longest and highest span. This is basically a truss to stabilize the last concrete girder. Because we were not able to guarantee that it will not collapse on itself because it was too long. So we used that we installed it with a crane. It was resting on each piers, and then with DWDAGs, we clamped the beam together. And you see later on in the picture that we just slowly chew between each DWDAG, and it was remaining stable and safe at every step of the process. Another thing we did, we had 3 sections with pre-stressed asphalt girders, concrete girders, and some of those girders were over a bridge. So to avoid any sudden collapse of the girders, we kind of designed a C-clamp, same principle as the piers, with a counterweight way back. So if at some point the girder wants to collapse, those clamps were holding the girders in place so we could mechanically process all the girders one by one. And this was moved by excavators on top. They were just pulling them, tightening them with some jacks, and then we were going along the way like that. Again, another 2 different systems using the same kind of materials. The idea was always to have something that we can reuse, because every weekend we had to start again. We designed, with the help of Kiewit, a platform to build over the railway so we can work without stopping the trains, basically a temporary bridge. And on the left of the screen is what we use to protect the main machine canal bridge when we were demolishing the spans, and also the pier cap and part of the columns, because there were some cars running right on the side of it, and there was a brand new bridge underneath it. You're going to see it in the picture right after. So quickly, this is what it looks like in a plan view. So you see in that section, we had all the major conflict at once. We have the railway, which we installed a platform over it. We have 2 piers that needs to be stabilized, so we installed the stabilizer with the counterweight. We had the deflector on top of the bridge that was deflecting the concrete down below on an existing rail that needs to be protected also. And then on the right of the screen, you can see how we were working with the platform. We were resting excavator on top of it. That's for the machine canal section. Can you please? Yeah. So again, quickly, there's like 100 pictures. I want to show them all, but just to highlight the type of protection that needs to be done and how it was looking like when we were performing the work. So we can see here it's daylight. Right at the side, it was an arena, people going in and out. That's temporary shoring that we use. In that section, that's the only section that we cannot touch with the iReach, because there was too much structure on each side. So we sit with Kiewit, develop a plan to cut and lift this span. We use a crane from Mammoth, 1600 cc 160, 600 quarter crane. And then the last section was removed with a 600 ATC crane from the ground. Again, that's a nice view of the city if you never went to Montreal. Quickly, that's the work that we did to protect the bridge. This is the installment of the temporary bridge process. You can see the conflict. We use crane. I think the next picture shows how close it is to the railroad. No, I missed it. Right there, you can see the car passing, and the platform, there was like 6 inches of clearance. And then you can see at work how it's looking like. All the pictures that you've seen were taken during weekends, mainly Saturday, Sunday, sometimes Friday night. We were working 27, as I said before, 24 hours a day. This is one of the devices we use. It was basically an old bulk carrier, steel carrier that we installed panels that we can deflect and collect concrete falling from the ground. At some point, we even had to install an excavator on it because there was a problem with the sequence, and we want to make sure that we could reach on each side. So we can see how all the work was performed with iReach, except on those closed tight area. That's another pier cap that we lift off because it was too unstable to demolish mechanically. That's the build of the platform over the rails. We had to install this platform 2 times because we had 2 structures crossing over the rails. And then you can see after, that's the setup you see in the drawings, the platform, the deflector, and then the iReach starting to munching the ramp, sorry. That's after. Always, it looks always easier in the picture. You see before and after, everything is done. That's the pier demolition process using this bulk carrier. Again, winter conditions. This is the system that we were talking about. The box that was holding the frame that was holding the pier, sorry. This is earlier this year. That's kind of the last stretch of the project going north. That's the new Saint-Jacques Bridge that you see there. We worked a lot from the top with small excavator. That's one of the key elements of the project, to be able to work from the top and also from the bottom, always to be as safe as possible. Again, I'm going to fast pass to this. Time is flying by. These are good pictures. You can see the work of the I-Reach with the deflector. We use dust buster almost every weekends. That's the result after. This is where we installed the super truss on top of it. You can see train passing by. We just had to wait during that process. This is when we installed the truss. Now you see it in action. You see the I-Reach working, and now it's easier to understand how it works. But you can see it's holding the last piece in place, and we were just demolishing between each of them, going all the way to the piers, and after we were transferring the truss with the crane to the next section, and we were going on like this, on and on and on. There's a few piers that we, every time that it was safe, we were dropping the piers instead of demolishing them in place. We basically built big burns and then excavate the front of the piers all the way to the footing, and with the excavator we're just pushing and then it just slowly collapsed on the concrete piers, but most of them were demolishing mechanically. This is the section east-west. Again, quickly, on a fast pace this, you can see the proximity in the new bridge. We use a lot of old crane mats and also blast mats to protect rails, barriers, top of abutment, steel plate. We try to use everything that we could be moved, install and remove fast, because again it was on weekends. At 5 a.m. every Monday the car needs to pass. This is picture like on Monday morning. Everything is Sunday night, sorry, everything is almost completed. We just have to sweep the road for it to be open. This is the way that we protect the channel. We basically build an ice bridge with the help of Kiewit to get the authorization. We basically pump the water from the channel with the snow cannons, and we just build snow for 3 weeks straight. We roll it, compact it, and then at the end we put crane mats and granular materials for the I-Reach to be able to go there. This is the C-clamp in action. These are the section over the canal. You don't see it, but this is the where the ice bridge is. We use a lot also of OC containers. These are cheap and easy commodity to gain. Everybody can use that and found that quickly. We have to use also imagination sometime. You're in the middle of shutdown, there's a problem with the protection, so we start with the engineer, install a plate on the SkyTrack, and then we keep the work going. Again, here give you a good sense of how we were close from the neighborhood. If I remember quickly, from the corner of that roof to the corner of the piers, there were less than 3 meters. A lot of screens with cranes to be able to work during the day, because at some point weekends were not enough. We had to roll every day. Dust control. So I think it gives a good sense of the kind of challenge we have to face in terms of phasing and demolition work. There were some unknowns into the challenge. As I said before, one of the solutions was target pricing for everything that has to be developed. But we also find out inside the box, a lot of repairs was done with high strength concrete during the years by the ministry. That was a challenge for the attachment mainly. The concrete reached from 55 to almost 90 MPa, which is not really standard of all structure. When we were working at height, that was the really dangerous situation, because you can see here in red, what is highlighted is the repair. You can see the detail at the left of the screen. At that height, with the attachment that we have at the end of the I-Reach, we were not able to break the concrete. It was too strong. So in that kind of situation, all our sequence was kind of thrown off the window. So the repair sometimes was just cracking and falling to the ground. If you're in Greenfield, it doesn't matter. If you over a new $60 million bridge, you don't want that to happen at all. So what we did at the end, we sat down with Kiewit. We had them survey the entire north and southbound, so we could put all the repairs into our drawings. And then after, redone the sequence accordingly to make sure that we never have to face a situation that you are 100 feet up in the air and you have an element that is unstable that you cannot safely demolish. So this part was a challenge. There was a lot of back and forth with the engineer, but at the end we were able to tackle this challenge also. Again, proximity with the community, big challenge, multiple stakeholders. All this was managed mainly by Kiewit. A lot of communication from the ministry also in collaboration with Kiewit to the residential area around, also to the user of the road, because they had to be informed when there was major shutdown. And at some point, Kiewit, with the fire department of the city of Montreal, decided that they had to move a family. I know it was a challenge. We talk a lot about it. When you try to move a family for a few days out of their house, when everybody's working, everybody's going to school, they don't have any cars, so it was really coordination effort, and we have to redone the sequence entirely to accommodate that situation, and I think we did a great job on that. Health and safety, key topic of any project, work at height, dust control, debris protection, winter condition, noise, community. What we did basically, we developed a fall protection for the demolition equipment. I'm going to show it to you after. We also developed alternative dust control measure. We didn't reinvent the wheel, we just tried to bring the water closer to the work. We had multiple screen and device that we use into the project. Mitigation measure to deal with the winter condition, and Kiewit built a lot of temporary noise wall around the neighborhood to control all of this noise. One of the solutions that we came out, because you had to understand most part of the work was done during winter, so we had slippery conditions with excavators on top of 100 feet high structures, so we want to protect the workers and also avoid any incident with the equipment. So for every time that the shovel was working on the wider, let's say, span, we installed some kind of a bump line made of steel. Looks pretty in the picture, but it was pretty heavy. But the way that we designed it, it was able to be moved and installed by the excavator without the operator has to go out. So basically you had to punch the slab with a hammer. The bump line was built with some kind of pin that was going out. They were installing that on the deck, pushing it to put some pressure, and then they were just putting the excavator right there on the bump, and then they can move freely without any fear of sliding out. Another thing we did, we had a lot of ramp, one or two lane ramp that was about 10 meter wide, and we were always removing the outside box from the bottom, mainly when we were over structure, because we never want to finish over a bridge. We always start on the bridge, clear the conflict, and then we were bringing the I-reach after. So it's a simple device, but was really useful and also really effective. It's basically a steel frame with the capacity to retain any machine, okay, traction power. And we were using chains, or not chains, sorry, wire slings to fix the excavator. It's worked a bit like a leash, a dog leash. So they were able to move from side to side, but they weren't restrictions. So if you imagine, I'm here with a shovel, and then like any workers working with a harness, safety harness, they were fixed. They were able to work like this. And when they had to move, they simply go back, pick up the device, move it a few meters, and then they were starting to working again. So all that, the intent was to avoid having any workers on top of the structure outside of the machine. And when they were going in and out of the machine, they had a designated area that you can park the machine, go out, safely put their harness, use a man lift, and then go down to the ground. For debris protection, we normally see big net screen, and for that particular project, it wasn't effective at all because we were moving a lot during the day. So we had to came out with something that the crane could move quickly. So we decided to have a two set of protection. We had a primal protection directly on the attachment. It looks a little bit silly, but it worked pretty well. If you want to try that on your project, you're welcome. We basically use old conveyor straps that we cut and fixed at the end of the quick coupler so the attachment can move, but I'm going to call it the mud flap, is always going down. So when any projection was going out, it was captured by this one, and then we installed a secondary screen, which is a steel plate 20 by 20 that was hanging with a crane. So we had 2 levels of protection, and it ended up working pretty well, and was really mobile. So during the day, you can move 6, 7, and 8 times without losing really much time. So that's one of the solutions that was really effective for us. Dust control, again, big challenge, especially in winter conditions. Dust busters work really well, but when you work into the city, the water is always going into the wind, and then you paint all the house gray surrounding your work. So we had a lot of coordination with Kiewit to first be involved with the citizens, for them to be aware of what's going on, and also to have a program to come back and clean whatever was full of dust after the work. Because it's not the water was doing its job at the source, but the migration of the water to the urban area was the problem that we had. So what we did, as many others did before, we just tried to be closer as possible to the source of the dust emission, and also we installed the dust control straight into the shovel. That was also really effective with the iReach. But again, when it's minus 20 degrees Celsius, not good. Finally, one of the best offspring that we have with, let's say, lessons learned of the dust control, we implemented, I'm a project man, I'm a PMP, so I love plan. Everything has a plan. Dust control plan implementation, so basically what we did was a simple form that needs to be filled out every day by the supervisor on site, but it was forcing them to think about what's the condition, what's the wind speed, where I should put my dust buster to have the maximum efficiency on site. And also, especially during those weekend shutdowns, you know what the condition you have on Friday night when you start, but you don't know what's going to be on Sunday morning. So we try to use any wind predictions so we can move the dust buster along the weekend, and also be able to communicate with the people that might be impacted by your work. So all was done during the planning phase, and then each day at each change of shift during the shutdown, we were re-evaluating the position of the dust buster, if it was efficient or not, and then we make the change accordingly. Quickly, best accomplishment of the project from our part, 0 lost time, no injuries. That's the key for us. Whatever happens, nobody needs to get hurt. We want everybody to go home at night. We had more than 90,000 man hours, mainly operators hours. More than half of that was done during weekend and overtime. We managed our way to demolish 360,000 tons of concrete that was crushed and reused on site by Kiewit. During the last phase of the project, we were averaging 20,000 tons of concrete per month. That's a lot if you consider that you're only working during 12 days a month. 50,000 tons of steel was recuperated and extracted and sent to the Aim facility out of the concrete. Again, special thanks to Kiewit. Without them, I don't think this could be possible. And then classic project team picture. That was the key of our success. That's it.
So in the sake of time, I'm going to ask that we are running behind, and we do have a 2 o'clock start for our afternoon program. So capture Simon in the chow line or someplace else, maybe the beer line, whichever your preference is. But please help me in thanking Simon again for a great presentation.